What is ecology? Ecology is the scientific study of the interactions of organisms with biotic and abiotic environments. Abiotic meaning non-living, for example, rocks and sun. Biotic meaning living, for example, trees, grass, and other plants. The term derived from ecology, a word from German biologist Ernest Haeckel, constructed in 1866 from the Greek roots oka, meaning house, and logos, study of. By house he meant the total relations of the animal both to its abiotic and biotic environment. Ecology system can be small or large. Individuals remove material and energy from the environment, and organisms are able to convert the energy and use it for their benefit. The sun gives off energy to the plants, and the plants are eaten by the primary consumer, which are eaten by the secondary consumer, and so forth. The secondary consumer produces waste, which is then broken down by decomposers. Then the nutrients go back into the soil. In the ecosystem, there are many groups of organisms coexisting in the same time and in the same place and are capable of interbreeding with each other. This term is called population. The population is determined by the interaction and exchange between the organism and the environment. Having different species in a particular ecosystem is called a community, and having multiple communities in a landscape or in an entire biosphere. In 1935, the British ecologist Sir Arthur Transley first introduced the idea of an ecosystem. Influenced by a man named Raymond Lindman, he was able to define the properties and exchange of matter and energy between biotic and abiotic components in the system. Eventually, the ideas bloomed into the fact that state latitude, gratitude, and solar energy input drove climate patterns. Weather is defined as the average state of patterns of variation over longer periods of climate. Seasonality, however, is the greater fluctuation in temperature over the course of a year. Population density and size are two measures of abundance. The population density is the number of individuals per unit of area volume. Population size is the total number of individuals in a population. Ecosystems are interested in the population size. Birth rate and death rate easily fluctuate and determine the population size. The BD model, aka the birth-death model, is defined as birth minus death equals delta n. The present population size. The value B minus C is the difference between per capita birth rate and per capita death rate, and represents the average individual contribution to total population growth rate. Interspecific interactions are interaction between members of different species. Interspecific competition refers to interaction in which members of two or more different species use the same resource. Parasitism is a parasite organism consumes part of a host individual but usually does not kill it. Parasites are generally smaller than their host, and mutualism is an interaction that benefits both species. The relation between is a perfect example. Commensalism is an interaction in which one participant benefits while the other is unaffected. The brown-headed cowbird follows herd grazing cattle, foraging on insects flushed from the vegetation by their hooves and teeth. In this example, the cowbird had no effect on the fitness of the ungulates. The regional distribution of species often takes the form of a metapopulation, a closer-distance subpopulation in separate habitats, patched linked together to the dispersal of individuals among them. The BID model adds immigration and immigration to BD model. Immigration can reappear in an area where population has gone extinct. It is really important to know that population growth rate by knowing the life history of a species so it can easily be recognized. The knowledge can be applied to a measure to reduce population of specific considered desirable or useful species. Conservation efforts give priority to protecting the largest remaining population. As population grows and becomes more crowded, birth rates tend to decrease and death rate tends to increase. K can be thought as a number of individuals that environment can support indefinitely. When population reaches K, each individual has just the amount of resources it needs in order to produce offspring to exactly replace itself before it dies.